So welcome everybody to the BlueJeans Relay Architecture Bootcamp / podcast. I'm your host, Ben Hutchison, and I would like to acknowledge a couple of guests we have here today who also work on Relay with me. I know that Josh and Ben and James are on the call today. Thank you for all of your amazing contributions to Relay. We also have some emeritus people who worked on Relay, Luke and Nick, and Amal, who is still at BlueJeans, but on a different project. We've also got Satya on product management, as well as a whole bunch of people who've helped us along the way on development, some interns, and some testing folks, and some product management as well. So thank you, everybody. So overall, Relay's mission is we want to make it easy for people to get into BlueJeans meetings with their room systems and endpoints. This is what we drive towards. This is what everything we do has to be about. So all the features that we're adding, they're aimed towards this goal. Just to set the stage in case anyone is more familiar with soft clients on a desktop or on mobile devices, when we're talking about room systems or interchangeably endpoints, we're referring to dedicated hardware appliances like these that are basically set-top boxes for joining BlueJeans meetings. They're not general purpose in the sense that they don't run Windows or Mac OS or Linux. They run embedded Linux and they usually just only join video meetings. So this is what Relay is controlling. They're not made by BlueJeans, so it's different from the Huddle team, which mostly works with platforms like Dolby and Polycom, where we're running our own clients on those endpoints. Relay is different than that. We are using endpoints where our own code is not joining meetings on these endpoints. These are made by companies like Cisco and Lifesize and Polycom. We're just trying to control them. So this is where Relay's responsibility comes in. These are just some examples of some devices and accessories that I had lying around my house. The SX20 in the top left is what I'm currently joining the meeting with right now. Actually, the entire top row is what I'm using today. So when we're talking about room systems for endpoints, this is what we're referring to. And the problem we're trying to solve is that these things, however great they are absolutely terrible for getting into meetings. They use remote controls or touchscreens, and the remote controls are just the worst things you've ever used in your life. After you've mistyped an IP address or a meeting ID into these things, you will want to just not join the meeting and throw the remote control out the window. Having to pull up your phone and unlock it and get into your calendar app just so you can find a meeting ID so you can type it is a complete waste of time. Most of the instructions we provide to people on our website or placards just have people go straight to the IVR with an IP address and then type the meeting ID manually. It's a huge waste. This is why we invented DNS for going to websites, and this is why we shouldn't have to have people type in the stuff manually ever. So we are trying to make things as seamless as possible so you can use your existing calendaring tools. You've already scheduled this meeting in Google Calendar or Office 365 with Outlook or something. It already has all the information right there in your calendar. You shouldn't need to do any extra action just to make the system understand that that's the meeting you want to join. We have all these cool scheduling add-ons that work with 365, that work with Google Calendar. They're able to schedule BlueJeans meetings with your personal meeting or with a one-time scheduled meeting. Those already do an amazing amount of work just to get the meeting into your invitation. We should be able to leverage that and make it really easy to use the information after it's already there. And what we found when we cracked open these room systems is that even though they're really cool, they're kind of a joke inside. This is a picture of an actual CTS powered by Toast, and what we're trying to do is make these work better. So the solution we come up with is to build a very generic platform that allows people to use these room systems in a service type way. So we've got a public API, it's extensible, we document it, we let you do whatever you want on it. It's not like there are hidden features that you have to hack your way into getting or that we withhold from people. You can do whatever you want on this platform. We try to strike a balance of delivering common things that people want that are more specific, like handle this one meeting case, while also being very flexible so that people can get creative and do whatever they want. If they want to join meetings based on some other trigger or event, they can do that because it's a public API. It's not a self-serving API, it's for everybody. We do use it ourselves, so we do eat our own dog food, and we build all of our admin UIs and our clients based on this one single API. So we know it's good enough to handle all these cases we've been able to throw at it so far. So it should be able to be good enough for anyone else. In order to connect to on-premise endpoints, they're inside a firewall, and not have to have API users worry about routing, we've got an on-premise connector, which is able to interact with these endpoints, which are not publicly internet-facing devices. You don't DMZ these things. That's the fastest track to getting SIP spam and getting hacked. So we have network solutions for people around that. And what we found is that it's an incredibly desirable, sticky product, and customers, when they see this, they want to start using BlueJeans, and when they have it, they don't want to stop using BlueJeans. It is really, really beloved by people who use it, and we've heard that feedback on when we had forums and people who have actually experienced that. And for a brief period of time when we were migrating to Verizon's Google Calendar, we didn't have the permissions set up because it took IT a while to get through all the Verizon red tape to allow API access for Google Calendar, and I didn't have access to this for several months. I had to use speed dials, but that's now fixed. IT has muscled their way through all the problems, and I joined this meeting with a one button to push meeting join experience with my endpoint, and it was great. It was fantastic. It was all worth it. So we've been able to take those problems that we identified and inject enough smarts and brains into these endpoints to make them actually work in a nice, easy, don't have to think about it, just get me into a meeting, take care of everything for me way. There's a little bit of history here, just so you know where we're coming from. It's been around for about 10 years. Last month was the anniversary of me sitting down and saying, oh, we've got this cool hackathon coming up. Luke had an idea for how we can actually interact with APIs on these endpoints, which I didn't even know existed, and I wrote some code in my apartment in May 2012. Alger, for some reason, thought that Peter was doing some kind of hackathon project involved with this for some reason. I don't think Peter was, but thank you, Peter, for, I guess, being involved somehow. And Alger sent me some Poly API doc for their Telnet API. And we whipped up something that would talk to Ted Trace's EX90 and the HDX in the boardroom, and then had a pretty disastrous hackathon demo where I forgot that suspending my laptop with an SSH session open would kill the process that was running listener service. So the demo was terrible. And also we'd been working on it for weeks and like not shutting up about it. So everyone knew that we kind of cheated. So we lost badly. And then for a couple of years, it just ended up really being a not funded project where we just tried to wow customers with this demo we already had and then tried that out and then put it away again and didn't really work on it too seriously for a while. But after that, we put some more effort into it, hired more engineers, and now it's a real product. And we've created a towering edifice of engineering that I would now like to explain to you in excruciating detail in the next hour and a half about why each of these pieces are very, very important and why we can't change any of them. But the major pieces in this cathedral of technology are, we've got Storm, which is our cloud-hosted backend server, sometimes called an API server. It's our coordinator, and this is what handles all of our persistent data and like authorization and stuff like that. Anything that involves synchronizing things or anything that is system-wide, Storm will handle that. It's a Java web app. The listener service is the on-premise worker. That's what handles things that need to be on the same LAN in your customer network for talking to endpoints and talking to Exchange. It's really just to get through firewalls. If there was no such thing as a firewall, Storm would just talk directly to endpoints and APIs and customers' networks. But this is to access things that are on private networks for people. Admin UI is the web app that you load up in your browser, and it lets admins do things like provisioning and status checking. So it's just a very simple like administrative interface. And Relay Touch is the last piece, and that's an Android app that end users would use to see their scheduled meetings and then you can control an endpoint with it, like joining and hanging up. So we write all of these things ourselves, and there are also some other components that use Relay that BlueJeans makes, but that our team doesn't make, such as the equivalent of Relay Touch on iOS is the BlueJeans Rooms app. It uses the same APIs. It runs on iOS devices like iPads, but our team doesn't maintain it, so that's handled by the Rooms team. Visually, this all comes together in this simplified network diagram where we've got the Storm stuff in the top left, and the Storm itself is running in the web app container. There's some other pieces I'll talk about too. And this is just our centralized cloud stuff. And then on each customer's enterprise network, we've got a listener service that is able to punch out through the firewall with an outbound connection. And then that will be able to talk to your on-prem stuff. We do some cloud-to-cloud calendaring, as well as some on-prem calendaring, whatever the customer has. And then clients talk to the backend service here. And I think what's interesting about Relay is really the breadth of endpoints that we support. So these are all the different endpoints that we've added integrations for. And Cisco, the first one, is definitely the most popular in terms of how many endpoints people have. But there are a lot. And Cisco, Poly, and Lifesize are the big ones, but there are also other vendors as well. And people have all different kinds of endpoints, and we're trying to make it easy for people with any of these kinds of hardware to be able to get into BlueJeans meetings easily. So really the goal of Relay is to make a unifying control interface for all of these types of endpoints so that they appear the same and can be used the same without the caller having to have any specific endpoint knowledge, any per endpoint knowledge of how do I authenticate to Cisco, how do I push meetings to Polycom. You shouldn't have to know that. With Relay, we make that all common into one simplified definition of what an endpoint can do. It is more limited than what each endpoint can do, but it's consistent and it's the important stuff. So we've implemented, for example, a join meeting API call for every single one of these endpoints. And we'll talk more about each of these endpoints later on. Here's our lab. This shows all the different endpoints that we have in San Jose. There's a second lab in New Zealand, which has even more endpoints, and we're getting more by the day. But this is the San Jose one, showing a bunch of Cisco, Poly, Lifesize, and other endpoints. So this talk is basically split here between the cloud side stuff for Storm and the on-premise stuff for the listener service. And we're going to talk about Storm first. It's probably not as architecturally interesting as the listener service, so we'll get this out of the way first, and then we'll move on to the on-prem architecture. The Storm is a Java web app. It's a classic WAR. It runs inside Jetty as our servlet container, and we're just using very simple Ubuntu VMs on EC2. There's nothing really fancy about this. It's kind of just a straightforward, if you need a Java web app, this is how you make it kind of approach. We're not trying to be weird or do anything over the top or complicated. So we've just got our WAR. We're using Jersey for our REST API. We've got Spring for our dependency injection, security, and ORM data mapping. We're using Jackson for our JSON serialization. Basically, this is the greatest hits of all the libraries I really like. So just using the best stuff that we can find. I love all those, and they're really, really helpful. Hazelcast also runs inside Storm, but it's called out separately because it communicates across Storm nodes. It's a distributed cache that allows us to have an in-memory synchronized view of data, hash maps, and things for stuff that you don't want to be scoped to a single node, but that is not worth writing to a database like every couple seconds, such as endpoint health status. MongoDB is for the durable stuff. So it's mostly provisioning data, calendar data, stuff that needs to stick around for more than a few minutes, and stuff that you would be sad if it went away. Mongo's great. It doesn't have schemas. You don't have to worry about migrations very much. It's super easy to map it into JSON objects. There's nothing weird. There's no hibernate. I love it. RabbitMQ, we use that because it's for the firewall stuff we talked about earlier, where we need to be able to communicate through a customer's firewall. It's easier to make outbound connections for firewall than inbound. And RabbitMQ allows us to send messages in the opposite direction of where we established the connection because it's a persistent channel. So we use that so that listener services don't have to wait around and make outbound polling requests infrequently. It's a push in the opposite direction from cloud to on-prem. We've got some load balancers as well. HA proxy handles mostly splitting 443 traffic, which could either be going to RabbitMQ for WebStomp connections, or it could be going to Jetty for API requests or web requests. So it's able to inspect the traffic. It has logic that surpasses ELBs in that regard. So we use that to direct that traffic to the right nodes. ELBs are in front and they do TLS termination and they load balance between HA proxies. So we're using Amazon to just kind of figure out cipher suites for us so we don't have to worry about that. And all these nodes are high availability, so there's multiple of all of these. If anyone goes down, the others take over. And right now we are in progress making some great work happen on disaster recovery, so cross-region failover and replication. Josh has been putting a lot of time and effort into that, and it's looking very promising on pilot. Visually, the Storm architecture looks like this. Traffic comes in from the left and goes to the right. So ELB, HA proxy, and this all gets distributed among like round robining to RabbitMQ nodes. There's some special logic to help even out the load, in fact. And Jetty and Mongo are behind that, and they all talk to each other and are aware of each other. RMQ traffic always goes through HA proxies to balance properly. So this is what's in EC2. Storm-wise, it is the brains of the operation, and this is what we expect Storm to be able to do for us. Everything that's centralized, everything that isn't specific to an endpoint or exchange, it's responsible for. So it does periodic jobs. So it's not a simple web server. It does things in the background even when you don't ask it to, like checking health, checking statuses for endpoints. Is it in a call? Is it muted? Pulling calendars periodically to make sure we have up-to-date calendars for people. It exposes the REST API so that you can interact with this thing, both for our clients and for other people's clients. It also exposes the web UI, which is static site for HTML, CSS, and JavaScript that we build. It's mostly the admin UI, but there's also an API docs page that also gets served so that it's always up to date, and some how-to pages just for people to see. It handles all the authentication and authorization, which is mostly just handled by Spring Security based on a user database, but we also delegate to SIEM for a lot of authentication. And if you're using a SIEM user account, we are able to handle both password-based SIEM login and IDP-based SIEM login, which we will show in a minute. It handles caching stuff, so keeping track of everything we mentioned in Hazelcast. If you have an endpoint with a status and you want to know if it's online or offline, a user can request that from the API, but that doesn't mean we're going to turn around and send an expensive, hundreds of milliseconds, maybe multiple seconds worth request to a customer premise just to fetch that. We're going to cache it so we can return to you the status very fast. We don't just pull calendars, we also receive pushes for calendars. So Google Calendar and Office 365 have push notifications. When calendars are changed, we subscribe to those. We get webhooks over HTTP when they change, and we use a pull for push model, push for pull model where the push triggers a pull on our regular polling cycle, but faster. So you get immediate updates. I actually declined a conflicting meeting just now, and it went away from my screen as I walked over to the endpoint, so it's extremely fast. The biggest thing it does is parse calendar invitations. So you invite a participant to a BlueJeans meeting, you now have a calendar invitation with some URL in it, and it's our job to figure out what meeting that URL points to, which is surprisingly hard, and we will talk about that in depth. It's also got a timer, so if you want to auto-join your endpoint without having to touch anything, just when the clock hits the right time, it joins. We have that feature too. Ben added that a little while ago, and it's able to just handle the different scheduling requirements for that. Talking to the listener service, Storm will send messages when you need to do something. Like a user used the API of Storm to say, please join a meeting. We're going to have to send that request over to listener service, so we are able to create a message in RabbitMQ and send that out with the necessary details, endpoint information, meeting information, and also tell listener service to like pull exchange. There's a couple different things it does. We'll show that list of requests in a minute. And it also sends up analytics to Mixpanel so we can see what's going on. So this is all very centralized stuff. Storm doesn't really know what a specific endpoint is. It doesn't know the difference between a Cisco endpoint, a Polycom endpoint, a Lifesize endpoint. It doesn't really care. It's not its job. It just needs to know how to coordinate stuff. So Storm is our quarterback. Here's the SIEM SSO. I had to figure this out myself because it wasn't documented, but now there's a wiki page thanks to me, and it shows how we were able to use SIEM as an IDP for SSO-based login and redirect to the right places so that you can use this if you're feature enabled and you don't have an enterprise in relay. It will get automatically created when you log in through SIEM and you're enabled for the feature. It's able to just create the enterprise in relay automatically, so there's no separate enterprise provisioning that you have to worry about anymore. So that's really cool. So that's some logic that Storm has to worry about. But mostly the crown jewel of Storm's complexity lies in calendar parsing. So it's actually a lot harder than you would think it is, or maybe you work on a client team that has done this and you know exactly how hard it is. Anyway, here's what we're up against. We're trying to figure out what meeting an invitation corresponds to. And it's not just BlueJeans, your classic meet me meetings with just a meeting ID and a passcode. We've also got Primetime and Blue Teams for first-party stuff and a bunch of third-party stuff as well. Skype for Business, which you might think is dead, but actually lots of customers still pay for on-premise Skype for Business implementations. We have to handle those. WebEx and Zoom for just third-party competitors, and a bunch of CVI competitors like Pexip, Poly, and WebEx for joining Teams meetings, not using BlueJeans. So we support all of those. We also have to worry about writing patterns that don't just apply to HTML. We have to also have to handle plain text. Historically, Google Calendar has just been plain text meeting bodies, and Outlook has been HTML. So we have to handle both of those. You can't always assume that it's going to be like just one or the other. Subdomains are probably one of the trickier parts of this algorithm because they're optional and they appear at the very beginning of a pattern, and there's not a well-defined list of them. It could be anything. For example, CLPs, or customer landing pages, are really just subdomains. So you could have coke.bluejeans.com and you wouldn't know to start searching for Coke. You just have to search for something.bluejeans.com. And there's nothing in front of it. There's not always something in front of it because you may expect there to be an HTTP or an HTTPS in front of that, but people often just don't type that. So we really have to start looking for just a subdomain. And that's really bad for performance, as we'll talk about in a minute. The other challenge is that sometimes URLs are transformed so that security tools can redirect through their own proxies first. So if Proofpoint notices that some link in your email happens to be a phishing link, they'll shortstop that. To do that, they rewrite your URLs so the invitation body is different and you don't see bluejeans.com, you see proofpoint.com / a whole bunch of garbage that gets eventually redirected to bluejeans.com, but you don't know that. So we have to take that apart. The next two are really just complaining about how unstructured a lot of these invitations are. Meet Me is pretty good because it's just a URL that's some well-known domains, base domains, but a lot of other invitations are just scattered text that is not in a good format and changes and can be localized. And you're just grasping at straws trying to figure out if there's like a colon somewhere that you might be able to search for. It's truly awful, and we've had to make many changes based on that. Things are looking up for Blue Teams because we've done some improvements there, which we'll also touch on. And the Zoom stuff is just we're at their mercy whenever they decide to change their weird table formats, which they do sometimes. And finally, these things can be quite large if people make long threads that result in, they'll paste an email thread into a calendar invitation. So you might get multi-megabyte invitations, and that doesn't play well with the leading subdomain stuff that we mentioned. So we have to deal with all of these problems when we're parsing calendar invitations. The solution we came up with is this algorithm. One, we get rid of the head of the HTML because there's just a bunch of CSS in there. We don't need it. That alone saves us a lot of time, mostly with Outlook. There's a lot of like that weird MSO word styles in there. And we also, I think, use the first like several thousands of bytes instead of using the entire invitation if it gets too long, because usually what you want is at the very top. because usually it's a reply thread when there's a lot of content and you don't care about old stuff. So we chop it off, and we use a two-pass regex approach. I think this is somewhat novel, or maybe you just haven't seen it before personally, but we use a high-performance regex for the first pass and a low-performance but much more accurate regex for the second pass. The first one just looks for things like BlueJeans. Not BlueJeans.com, not a.bluejeans.com, not BlueJeans.com/12345, just BlueJeans. And we find a list of candidate regions of text around that BlueJeans occurrence, and we'll get as many as are in the invitation. And that's really fast because it's just looking for a string that starts with a well-defined character. The second pass looks within each of those regions, which are way smaller because they're not the entire invitation. They're like only a couple hundred characters. They'll look in there using a regex which matches everything we care about, from the subdomain to the base domain to the meeting ID to the passcode, anything else we need to find. And that's going to, if it were to be run on the entire invitation, it would be way slower, mostly because of the leading wildcard. With regexes, if you start your pattern with a wildcard of variable length, you can get into either an order n squared or a 2 to the n situation with long enough inputs where it will do what's called catastrophic backtracking, where it will match every character that it can find and then every character before that, and it will do that in a way that will eat up all of your CPU and just wedge your entire server. So we want to really scope down the amount of text that we run this on. And once we've run the first pass one, we have a smaller region that we can run the second pass one on. That will find individual patterns that we need, like meeting ID, passcode, subdomain. So that's where we get the actual data that we need to parse. There are a lot of edge cases around if two regions are too close to each other or just the right distance apart, they might slice a second pattern that didn't match it, that did not match the first pass, but did match the second pass because they're different patterns. And then you've sliced something in half and gotten a false positive. We've tried to stamp those out, but there I think are a couple left with teams, and we've mostly just given up and tried to make people use a different parser. We mostly deal with this headache by having a really, really, really good test suite. So anytime there's a problem with anything in here, we just, first thing we do, test-driven development, add new unit test. It's up to, I think, 138 test cases now. And if you make a change and it passes all of those, you're good to go. It's a really nice suite, and it gives me a lot of confidence that we have good calendar parsing. And we have all sorts of oddball invitations, from big invitations, weird ones, internationalized ones, stage, pilot, prod, everything. Performance-wise, we try to make sure that it does not take up very much time. We've had problems in the past where Storm has just been stuck on CPU spinning on prod because some customer had a huge invitation. So we must make sure that all of our parsers pass the Monte Cristo test. This was invented by a college friend of mine who liked to not fuzz necessarily, but test the performance or constraints of web apps by pasting the entire contents of the novel The Count of Monte Cristo into text fields to see if there was any kind of length limit. It's available for free on Project Gutenberg. You can download it. It's 2.5 megabytes of pure text. And if you have a catastrophic backtracking problem with your regex that isn't like, that would occur in normal English text, this thing will find it. If you have any performance problems, that test will fail. I think we have a duration limit on that test, in fact, to measure how long it takes. Not just that it passes, but that it passes quickly. So any parser we add, we'll have to pass that test. And it's actually really fast now that we have this two-pass approach. In fact, there was something we noticed where when I was working on Furiosa, if you had a long enough invitation or maybe certain backtracking situations, Furiosa would also suffer from the exact same problem. So we recommended that Edward take a look at our algorithm, and he liked it, and he ended up porting it to Swift. So now Furiosa likewise has an extremely high performance meeting parser for BlueJeans URLs. That's pretty much it for the cloud-hosted Storm stuff. The rest of the talk is just about the on-premise things. So I'm going to take a quick pause here because I think we're doing pretty well on time, and ask if anyone has any questions about Storm stuff or the overall project stuff. that's before we get to the on-prem portions. Cool. Next part is the architecture of the listener service. This thing, internally, I call it the sleeper cell, mostly to scare customers if they were to ever hear about our code names. It's just a Java process, runs wherever Java runs. It's a daemon that runs in the background. We use the EdgeSwift for our service management. And like we mentioned, its job is to be on a customer's network so that you can talk to endpoints that aren't publicly exposed to the internet. We've got a bunch of installers you can install on Windows or Linux, and Ben's recently been adding some features where you can have pre-built images for AWS and Azure that have it pre-installed, so you can skip the steps of having to install a JRE and download the artifact. Those are cool. We've also allowed people to do clustering and also have multiple clusters, so we can handle very high loads. Individual listeners can handle very high loads on their own because they're really quite light on CPU, memory, I/O, network and disk, and they mostly just sit around waiting for network requests to complete. So they can handle a whole bunch of endpoints at a time. But if you care about like doing hitless upgrades or handling very high loads, you can make a cluster of them. And if you want to have different endpoints in different regions, for example, I have 2 endpoints and each one's on a different subnet. Those 2 subnets cannot talk to each other. You could have 2 listener services, one for each subnet. Or if you just don't want to have to VPN across your global sites. This thing, as we mentioned, establishes an outbound connection to the Relay Cloud. That's an AMQP or WebStomp connection, and it will make that connection when the listener service starts up, and then it will continually monitor it to make sure that it's healthy. Lots of customers have terrible networks that just drop connections all the time, so it will try very hard to reconnect and make sure that the connection is always healthy, which for some reason a lot of these messaging clients like AMQP and other ones don't provide a good solution for that built in. They're very fail fast, so we've had to add a lot of that code ourselves in the form of custom consumers like the Tenacious consumer and that Nick's added. So that was kind of some unnecessary work, or work that should have been done by somebody else besides us, but it is there, and it works quite well at this point. So that's good. And in terms of stuff that the listener service contains for talking to remote systems, we've got SOAP, we've got SSH, we've got HTTP, we've got TCP, we've got both servers and clients. And we'll look at all of those in a minute. So this thing's job is to talk lots of different dialects to whoever it needs to talk to. So the responsibilities of the listener service is Storm does all the high-level coordination. We consider Storm to really be the brains of the operation. Listener service is not trying to outsmart Storm, is not trying to coordinate anything or plan anything. It's not dumb in that it has a lot of very specific, like specialized behavior that it can do that nothing else can do, but it doesn't make high-level decisions on its own. So Storm is the coordinator and listener service just does what it's told. And we found that separation of responsibilities makes it very, very easy to reason about, because anytime you have distributed systems where you have a lot of different decisions being made and different systems trying to outsmart each other, it gets very, very hard to reason about very fast. So by having this centralized coordinator and then fanned out worker model, it's quite simple to reason about whose job it is to do something and when something should happen and who should do it. The specialization it does have is mostly talking to all the different endpoints we saw on the list before, also talking to Exchange because it's on-prem usually. And it just sits around and waits for commands to come in from Storm over AMQP. They show up as JSON and we process them and we do whatever it tells us to do, like talk to an endpoint, talk to Exchange, and then we send the response back up to Storm. So it doesn't really respond to user requests very much. It doesn't have like timers in it or anything like that. There's minimal state. So So it makes it very easy to cluster because there's nothing to share, and it just does what it's told. Mostly it's trying to just, like we said, provide a unifying interface that makes all the endpoints addressable by people who don't need to know the difference between Polycom and Lifesize, for example. And here's a list of commands that it's able to handle. So anything Storm tells it to do is going to be one of these things. Like if you want to join a meeting programmatically, invitation is going to contain all the details about the endpoint, the IP address, username, and the meeting ID and cluster, and that sort of thing. Same thing for like muting the microphone or pushing calendars. But these are all the commands that Storm will send to listener service that listener service has to handle. And the next part is we just have a bunch of dispatchers that have the logic for dealing with every single kind of endpoint. We differentiate endpoints by referring to different control protocols. So like a Cisco control protocol would refer to using HTTP to talk to a Cisco endpoint. There's also like an SSH protocol for talking to a Lifesize room, Lifesize Express. So that differentiation is what we call control protocols. And then we've made dispatchers, which are clients which are able to use the APIs of those endpoints to talk to each of those control protocols. Here's a list of all the dispatchers and what kind of protocols they use to talk to endpoints and what kind of authentication they have. The top one, as we mentioned, definitely the most popular. People use a lot of Cisco endpoints. We use TXAS, which is the Tandberg XML API services. It's XML over HTTP. Pretty well documented, although the calendar stuff is secret. And the session logic is very complicated because of how many revisions there have been. There's a bunch of other stuff too. IX is completely a different beast than the rest of Cisco because it didn't come from Tandberg. So we have to use their SSH API, which is pretty cool, and their SOAP service for pushing calendars, which is very weird, and we'll talk about that. We've got a whole bunch of Polycom endpoints. They mostly just use a bunch of different JSON APIs. They're really not publicly documented ever. The only difference is that for trios, we got in good with their PMs, and they gave us the secret PDF that we can't share with anybody, so we know what the trio API is. Everything else is just we looked at the web interface and saw what requests it was making. HTX is so old it doesn't have an API, so we just scraped the web interface, which is atrocious. Icon is a pretty okay JSON API, and then the older Lifesize stuff is a really, really nice SSH API, actually. Lifesize, or Yealink, I made a maybe bad call initially to use web scraping because the TCP API looked too complicated, but they ended up rewriting the web API, or the web interface, basically. So all of our stuff broke, so we're trying to move to the TCP API. We know how to do it, but last time someone was in the office, they told me that the camera on our Yealink kept clicking. So I'm worried that thing's going to light itself on fire one of these days and burn down the office. So if you walk by the Catalyst lab in the San Jose office and you see any wisps of smoke coming out of the BC800 over there, maybe just like grab that thing and dunk it in a bucket of sand or something to keep it from exploding. Starleaf, they actually sent us a couple endpoints, which is cool. They have a very well documented JSON API. The auth handshake is ridiculous. I had to learn what PBKDF2 HMAC SHA-256 was in order to support that. And I learned recently that's not even considered to be very secure these days, so that's cool. Scopia, we'll talk more about that as well, but they have a raw TCP API where you send, I believe, it's mostly bit-packed, like bits over TCP. There's also some XML involved for calendars. Sony is a joke of an endpoint that I just added because I found one lying around and got bored, but it uses a web scraping thing for the web interface. No one uses it. And then Telly is out of business, but they are the only one I've ever seen where it is a JSON API, but it's not like JSON bodies, it's JSON query parameters. So you've never lived until you've tried to serialize a JSON object into a query parameter. Also, the auth happens to query parameters. They kind of had like one hammer that they could reach for on their engineering team, I think, which was query parameters. Next part is the Cisco auth thing that I mentioned at the top here. Is very complicated. So next slide, please. This is how we deal with Cisco auth. It looks real annoying, and it is. And This diagram is the only way to understand it because the code does not really like lend itself to this sort of flow. But we're basically trying to handle F firmware, TE firmware, TC firmware, CE firmware, and Room OS firmware. And the authentication changes across different like major and minor versions of those. Like sometimes you use basic auth, sometimes you use like an API to generate a session ID that gets stored in a cookie that you need to reuse. And other times, if you try basic first, it's super duper slow. So you should really use session auth instead of that, so you can not pay the price multiple times if you do multiple requests. But if you do that with an endpoint that doesn't support it, you're just going to get like a 302 to the login page. So you have to handle all that stuff. It's a big headache, and if you get it wrong, you'll end up spamming the endpoint with lots of either session requests or basic auth, so your solution will be very slow, or it will crash the endpoint with too many open sessions, which we have had happen. And I think TAC got involved in one of those, which was really fun. But the fact that no one's yelling at us means it works perfectly. We would hear about it if it wasn't. But yeah, this is complicated. Oh, the other thing with authentication filters is dispatchers are not responsible for authentication to endpoints. Dispatchers' jobs are to send requests for like a join request, for example. So knowing how to format the request, the body, what URL to send it to, how to handle the response. That's the job of a dispatcher for all the different like commands that we saw, invitation, hang up, all that. Auth is thorny enough that we don't want to have someone developing a dispatcher having to worry about auth while they're also worrying about what the dispatcher's job is, which is sending the real like business requests. So we separate all of our auth for all the different endpoints into a different layer. It's more of a like kind of declarative cross-cutting thing where anytime you inject a client in from the endpoint target factory, you're going to get a client target which has been fully prepared to do the correct authentication. Oh, sorry, we have an alarm going off. I hope you can't hear that. That way, all the auth is contained in its own separate place. And I'm sorry again. The filters are kind of like an interceptor, and they're able to like deal with requests before they go out and responses after they come in. So they are basically able to store cookies, read requests and responses, and they relieve the burden of thinking about that from dispatchers. So if you're writing code, you don't have to think about one or the other. And they're able to like replay requests and things. If you do a first one and then it fails, it can replay original requests without you having to have any retry logic in your dispatcher. So super convenient. And the next section is about my favorite feature of Relay, which is how we push calendars to the endpoints. This is called Deep Magic internally and probably also externally. And I think this is just the coolest thing in the world. This is one button joining based on the built-in calendars that room systems provide. So many of them have the concept of a calendar. Those calendars can have meetings. Those meetings can have join buttons that will get you into the meeting just as a single tap, like a speed dial, without having to type anything. And typically those are populated by other offerings, piece of software by that company, like Cisco has their thing, Polycom has other stuff. Our job here is to try to make all these calendars on the endpoints work with BlueJeans meetings. So by doing this, once you schedule a BlueJeans meeting on your calendar, it should show up on the endpoint and you can tap on it to join with no additional actions by the user. And we handle a bunch of different kinds of endpoints, got many different Cisco endpoints. TCC and RoomOS do it one way, IX does it another way. Poly has a pretty complicated approach. Life-size icons have their own approach. Room Express has a hack, and Scopia has their own approach. I was thinking about it, and what's common between all of these is that none of these are documented, and all of these require us to hack into something and reverse engineer it, because for whatever reason, even though some endpoint vendors are really good at explaining how to do join requests and hangups and all that stuff, they absolutely never, under any circumstance, want to tell you how to put calendars on these endpoints. So we've had to really pull some teeth to get this out. But it's really, really cool. At the bottom here, we can see some examples of what these counters look like after we push meetings to them. We've got Cisco CE firmware on the left. We've got TC firmware, which is older. We've got a life-size icon, and we've got Polycom. So we're able to push meetings to all of these things, and you can join all of them. We're going to start with Cisco, as is definitely the most popular, and also the oldest that we've had implemented in Relay. Cisco wants you to do this using a TMS or a CTS man or a WebEx. Our approach is most similar to a TMS. In fact, from the Cisco's perspective, we are a TMS. Sort of. They can actually tell because we don't have I think feedback URLs or provisioning URLs. But for the sake of this method, it works like it's a TMS. And I think LinkedIn wanted this, and Nick said, "Oh yeah, you can do that. CTS man is basically just do a post to this bookings put XML path, and you just have to figure out what the XML is." I was like, "Oh, that's cool. I'm going to go download a TMS trial and Wireshark it." So we did that, and we now know what that secret XML is that you have to send to that URL, and we're able to put the right data in that using the listener service to have all the different meeting subject and dial string and all that. Cisco kind of keeps flirting with removing this thing because of WebEx and stuff. Last time I tried it was 2 years ago, and some customers of ours got extremely pissed off and yelled at them until they put it back, including some forum stuff, and there was attack involved. It was really, really fun. It might go away again at some point, who knows. The most recent hurdle here is that the newest version of CE firmware, RoomOS 10, started doing a thing where the join button is disabled if you are not registered to any kind of like a SIP registrar or whatever your active control protocol is. So if you're registered to a VCS or CUCM, if that does, I think that does SIP registration, or WebEx, or anything like that, it works fine. But if it's standalone, like most of the Cisco endpoints at BlueJeans are, and also a lot of other customers are, it just will be disabled for no good reason. It's not like a technical restriction. You can definitely join meetings if you're not connected to a SIP registrar, because BlueJeans does over-the-top meetings. There's no on-prem gateway or bridge or anything that you have to talk to. It's just a cloud bridge. So it might be an oversight. I think it probably is because the reminder pop-up that shows you when a meeting is about to start does work in this situation. It's just that the home screen button doesn't work, so it's inconsistent. So I don't think they were adding something that was supposed to be like a safeguard or like a new policy. I think it was just like someone messed up. Anyway, we fixed this by putting a SIP server in the listener service that's able to act as a registrar. So the listener service, if you turn this on, it's off by default, but if you turn it on, the listener service will push configs to the Cisco endpoint that will point the Cisco endpoint to the listener service as its SIP proxy, and then this all works. It will then try to dial the listener service whenever you join a call, which we don't want. So our two choices there are either handle the call and actually proxy everything to like the far end, which sounds really annoying and also prone to errors if the listener service goes down for maintenance. So instead, we're able to somehow find a way to bounce the requests off the listener service and make them go to the original destination. Not with the 302, that creates an infinite loop as I found, but with the 305, use proxy. We tell it to use the original destination, which is like bgn.vc, instead of the destination it tried to use, which is like whatever the local IP address of the listener service was whenever it asks us to join a meeting. And that way it will stop asking us and it will start asking basically Copper or the SIP connector to please proxy me over to meeting ID at bgn.vc, which Copper will accept or which the SIP connector will accept, and it will just join you into the meeting. So I guess it's somewhat paradoxical that the use proxy response is used to make it not use a proxy, but it does work. This is what the secret XML looks like that you have to post to the, that's right, you post it to the bookings put XML URL. And this is the content of what that looks like. So you can see there's like a dial string down here. And there's the title of the meeting. So that's what the listener service is sending to the Cisco endpoints. And then here's how the SIP registration flow works. There's a flow diagram over here that shows that we check some stuff on the endpoint to make sure it's eligible, and then we push the config over to set like the IP address and the username and stuff like that of the SIP proxy. It then tries to register to us, and we say, okay, it's stateless, so we're not actually keeping track of who's registered to us. We don't care. We don't route calls to it. But we do tell it that it's registered, so the endpoint's happy, and this makes it happy. So at this point, we'll enable the join button, and you'll see that in the endpoint status, you've got the, we push the IP here and the username here, and we also have to make up the URI, can't be empty. And then if it all works, you'll see that the proxy is active and the registration is registered. So that's what you want to see. This only affects CE10, room OS 10, and later. So we don't do this if it's CE9 or if it's CE8 or TC7 or any older stuff. It's not needed. And then for the join request, it sends us an invite at bgn.vc to the listener service, which isn't bgn.vc. We then 305 back to it, and then it will go off and talk to actual BlueJeans, which is good. And Copper will 200 it after it tries to join that meeting with it as a proxy. Copper is tolerant enough, or the SIP connector is tolerant enough of that to handle it. There's also a different kind of Cisco endpoint that isn't derived from Tandberg. This is the CTS-based stuff, and it is basically the immersive room systems, like triple screen IX 5000 series. I'm more familiar with these because I worked on these at Cisco, but it's a terrible API. The SSH one is not bad. That's for like joining and hanging up. But the OBTP stuff is, again, a huge circus. So it's a secret SOAP API, and I can already hear you groaning. It also doesn't have any documentation or a WSDL. And Cisco is absolutely terrible about this sort of thing, especially WSDLs. At one point, we found some defect in like a Cisco multi-point bridge with their WSDL where it was wrong about some detail. And we reported it to them, hoping they would fix it so we could actually start consuming their API. In response, they deleted the entire WSDL. So Cisco really can't figure out how to do this properly, or at least couldn't in the past. We know that we were able to figure out on our own that this API existed, and that's how you would, this API, it's called TBCSS, is what the SOAP API is called for calendaring. We knew it existed, but we didn't know how to use it because our TMS wouldn't push to it. And as I said, no documentation. But Autodesk, who was a prospective customer, really wanted this. And we said, well, we don't have this set up. And they said, well, we do. You can come up to our office and we can just show you how it works. And if you need to capture anything, we'll do that for you. So we drove up to San Rafael, and they had their TMS VM with Wireshark already installed on it. They had their IX5000. We were in the room. They had it already set up with encryption turned off. So you would just send like raw HTTP without HTTPS. And we said, okay, please schedule a meeting on your Exchange server. And TMS-EX sent it over to the TMS, and it went over to the X5000. We captured the packet with Wireshark, and then they emailed us the TCP streams that came out of that. And now we had the contents of those SOAP requests. So we went back and added that to Relay. And then because of some internal politics, they didn't buy BlueJeans, they went with Skype for Business. But at least we had this golden packet, or two golden packets technically. And this is pretty much what they gave us. I took out the password and like passcodes and stuff, but everything else, this is what they gave us. So if you need to send OBTP calendar rotations to an X5000, this is how you do it. Our approach was actually to take this, and it's not just sending it raw. I wrote a WSDL which would have generated these requests and responses, and then we auto-generated an access to API client, a SOAP API client based on that WSDL, and that's what's in the listener service. So that works. That's the Cisco deep magic. Life-size icon has its own way of doing things. Atlassian loves this stuff, and this is architecturally pretty similar to the Cisco approach, where you have some on-prem device that will push meetings from it onto the endpoint. In life-size world, that's like UVC manager or whatever they call it, which is kind of discontinued, but that's what the assumption was when they built it. They have JSON REST API. It has CRUD methods for the meeting stuff. It calls that family of methods for doing meeting stuff manager after UVC manager, which is a stupid name because there can be plenty of managers in a code base. You probably shouldn't call something manager, but that's what they did, so that's what that means. The methods, like signatures, were very well documented, but the payloads were absolutely undocumented. So we had to dig up these Ruby scripts to see like what we actually sent to these things. We eventually got it working. The one weird thing was that in newer versions of these endpoints, they have the ability to fetch meetings from a cloud service. That cloud service is moronically called a microservice, which is especially silly because there's the idea of microservices, you have more than one of them to handle different roles. So they called it that for some reason. If that's enabled, it turns off the manager API, and some customer couldn't figure this out, so we had to go in and save their butts on that one. But we got that working. This mostly works on older icons. There's two generations. There's the 1080p versions, which is like the 400, the 600, and the 800. Those are older. This works fine with those. The newer stuff is the 300, the 500, and the 700. Those are 4K, actually. They're pretty nice. We have one. But they got rid of the manager functionality because they expect to always be fetching meetings from Lifesize Cloud. So we don't have a way to become Lifesize Cloud or put meetings into those. So currently there's no way for us to get meetings onto those endpoints. Surprisingly few people have asked for it. I think Lifesize is pretty declining in popularity, but we did have a good meeting with them where we explained what we wanted to do, and they seemed happy to at least talk to us, and they explained why they designed their system the way they did, which made sense and was pretty reasonable. And they offered that if we wanted to show them an architecture of what we would like for our ability to insert custom meetings into their Lifesize Cloud backend, that we should just send that to them and they would look at it. We did send it to them. They didn't look at it. But, I guess that was the best we could do. Anyway, here's some pictures of what a Lifesize DeepMagick success looks like. There's the TV screen itself. There's the TV screen with the details of an invitation. There's the touch screen that shows up. And then there's the join prompt for the touch screen if you tap on it. So it does work pretty well. It's not the worst API. It's pretty simple. There's some weird pagination stuff where you have to if you want to list the existing meetings, which we do because we have to clean them up if they've been elapsed or declined. You have to you can't just ask for an array and get an array. You have to instantiate a handle and then enumerate that handle. So it's very enumerator based. I think it was mostly designed for local Ruby processes and not remote processes. But anyway, that's how you do it. This one's pretty simple. This is older Lifesize endpoints, much older, like the first ones we ever used older. They don't have calendars. They really use join meetings by typing stuff in or using redial or speed dial or a directory. And no one really asked for this, but we added DeepMagick support by just inserting and removing calendar entries, which are actually directory entries, into a special folder of the directory. So it may look like it's a calendar, but it's really just a bunch of directory entries, like it came from LDAP or something like that. And that's able to just have a start time and an end time of your meeting as part of the title. It doesn't have reminders. It doesn't have any kind of notifications or anything like that, but it does let you join it without having to type it. You did have to parse a table, like an ASCII art kind of table of what's already on there over SSH, which is pretty fun. Really doesn't really do string manipulation very much, but we did have to do a little bit here to figure out what objects were already on the endpoint using SSH. So that was really cool. The other responsibility that we had to add here was typically time zones are handled by the endpoint because we'll tell it the time a meeting starts in UTC, and then the endpoint will render that in whatever time zone has been configured for. For this one, since there's no calendar, it's up to us to format the times correctly. So we need to fetch the locale because different locales have different time zone formats. And we also have to fetch the time zone so we can convert the time zone into that format before we make the title of this directory entry. And fun fact, if you ever deal with time zones that Microsoft has ever breathed on, you're going to see Mid-Atlantic, which is fake. It's not a real time zone. It does not exist. It never has existed. There is no comparable zone in the Ayanna Olson database, TZDB. And it's -2, but you would think you could just use like etc slash UTC -2 or +2, I guess. But you can't do that because this thing has DST, daylight saving time. So there's no existing mapping. Anyway, I added a custom zone for it that doesn't help anybody, but it was very informative. If you ever see Mid-Atlantic, though, just know that it's fake. It's a lie. It's made up. No one uses it. I don't think there's even any like populated land in that region of the world. Definitely none that observe this time zone, for sure. So that's life-size deep magic. So we've covered Cisco and Polycom deep magic. Next, so we've covered Cisco and life-size deep magic. Next is Polycom. I think this is the most complicated one. This is one of the weirdest things that we do in all of Relay. Unlike Cisco and life-size, you can't push meetings onto a Polycom device because they don't reach out, or they don't expose any APIs that do that. They only reach out to an Exchange server, which really sucks if you're trying to use Google Calendar like Verizon is, because it's not going to have a client for that. So all it can do is ask an Exchange server for meeting items. So our solution is to make the listener service appear to be an Exchange server for the purpose of tricking this Polycom into asking for meetings. We call this pseudo EWS, where EWS is Exchange Web Services. That's the SOAP service that Exchange servers expose that Poly uses. We also have a real AWS client. Like that's how listener services get meetings from Exchange, but they're two different things. One is a client for getting real meetings from a customer's Exchange. The other is a fake server for providing synthetic meetings to a Polycom device. So they won't be the same invitations. They'll have like stripped descriptions and different dial strings, even if they both technically come from Exchange. And also, to be clear, this is able to push Google Calendar meetings to Polycoms. Because again, the EWS meetings that we're exposing are synthetic. You can take a Google Calendar meeting from Relay and then put it into these fake EWS meetings so that Polycoms can use them. And it thinks we're an Exchange server. We automatically set all the configuration that you would need to on the Polycom, like the IP address of the listener service, username, password, that kind of thing, domain. And once it does that, it will start asking us using find item and get item SOAP requests to enumerate meetings for a given mailbox. And we are able to just turn around in the listener service and figure out what endpoint that represents and fetch those meetings from Storm using the REST API and return those to the endpoint. The actual SOAP requests are pretty easy to deal with. Like you could do that pretty simply. You can intercept the requests from the Polycom to like Office 365 or on-prem Exchange server. You can just use like Wireshark or whatever. And you're able to get the, like as long as you can get through the HTTPS, you can figure out like what those requests and responses look like. They're also very well documented. Like Exchange has a bunch of documentation on what those different methods take. So we just return XML over HTTP. We don't have like necessarily a SOAP layer there. There's no access server. It's just we have some XML documents we create. The hard part is authentication because Exchange by default uses NTLM authentication, doesn't use BASIC. That's how EWS is set up. So Polycom didn't bother implementing a BASIC client. They only implemented an NTLM client. I think it's curl. And there are no Java NTLM server-side modules. The only one I found delegates to a real Active Directory server, which is completely unhelpful for us. So we just had to write our own. Luckily, in the bad old days, I think Apache had to reverse engineer the NTLM protocol, which looked like just the worst job in the world. In the time since then, like before I got to this, Microsoft actually opened up the documentation for NTLM, which is real big of them. And they described all the different things you have to do, both on the client side and the server side, to do this three-way handshake. So I basically really wanted this to work and sat down and wrote what I think is the world's only server-side module for doing NTLM auth in Java, and learned a lot there. A lot of bit manipulation that is sadly missing from Java. I had to add in myself. If you've ever used the bit converter class in .NET, that's what's missing from Java. And there's a bunch of hashing garbage, including some things that you probably won't be very impressed by, like DES and MD4, which is hard to use in Java because it's so old and discouraged from being used. Also, a lot of clients have like or quirky behavior that is not part of the spec that I think IIS paves over, that we have to also figure out and pave over experimentally. This was a gigantic amount of fun, and I'm so glad that it works. I don't have to think about this anymore. Here's some of the bytes that we have to deal with. The stuff at the end is kind of like not that important. It's just host names. The actual real data is mostly in here with these inscrutable bytes. So that's really, really cool. This is a picture of it actually working. This is a Polycom Real Presence Touch hooked up to a Real Presence group series showing some meetings pushed by relay. This is from the Top Gun room in the old office. And here's some pictures of other various endpoints that they're showing Polycom Deep Magic. We've got a trio. We've got a debut. I was trying to figure out NTLM v2. There's 2 different versions of NTLM. And it doesn't tell you which one it is. You have to guess. And you have to handle both of them. This is an HDX. And then this is the Polycom Touch Control, a much worse tablet than the one we saw on the previous slide. I think it's actually connected to a Real Presence group series at the moment, but if you flash the firmware, you can make it talk to an HDX as well, which is the only touchscreen that can talk to HDXs. Anyway, it's terrible. The next one this is the last Deep Magic implementation we have, and this is a Viascopia. It is at the bottom of the list for how much people want it, but we've got one customer, or one former prospective, I don't know what they were, but VideoJet really, really wanted this, and they just mailed me a Scopia out of the blue without any explanation. It just arrived at the office at my desk, and there was this endpoint with a broken camera and a note on it that said camera doesn't work. And if you hand me an endpoint, I'm going to add Deep Magic support to it, so I did. Had to brute force the menu password. I tried a couple common things, and it was like maybe the 5th or 6th one I tried is 2468, I think. And I figured out that the architecture for meeting pushing, I mean, the actual talking to the endpoint, like join and hang up like normal stuff, that's just packed bits over TCP, which is very well documented in a huge PDF. So we have a very nice set of Java classes I wrote that handle that in a really easy to follow way. It's nice encapsulated. The calendar stuff, once again, is this impenetrable mess that no one documents or wants you to use. So we had to figure that out on our own. It's basically similar to the Poly architecture where it reaches out to get meetings from something else. It doesn't allow you to push meetings into it, Cisco. And in their case, it's not Exchange. It's the Scopia management server, which is this all-in-one coordinator that runs on-prem. It handles calendars, it handles provisioning, it handles actual calls. Like it's a call engine as well. Like it's a B2B UA or something, or at least a proxy. And it expects to be able to fetch meetings from this thing, not using that bitpacked TCP API, but a different secret API. So once again, we send requests to the Scopia endpoint to tell it that we are its Scopia management server. In fact, we're a listener service, but it can't tell that because we expose a lot of the same methods it needs. So it will ask us for meetings on this other secret API that isn't the well-documented bitpacked TCP. This is just XML over raw TCP. It's ridiculous. There's also no authentication on this, by the way, in case you're wondering. And we will turn around, similar to Polycom, we will fetch the meetings from Storm's API, and we will go ahead and return those over XML, over that TCP socket to the endpoint, and it will be able to show those on its calendar. For H223, the story ends here because that just works. For SIP, the story keeps going because with SIP, it assumes that the Scopia management server is actually the bridge for all the meetings. So it will, if you have some dial string that's like 12345 at bgn.vc, it will ignore the host bgn.vc there, and it will just think that the scoping management server, that's my bridge. I'm going to send all of my invitations to that thing. So you get 12345 at like whatever your listening services IP address, like 10.4.400 or something like that. And similar to Cisco, this actually came first, but it's the same approach. When we get an invite message on our SIP proxy, we will respond with a 302. So that's going to redirect the call from the listener service. It will turn around and make another invite request to bgn.vc. We're able to keep the listener service out of the signaling flow, except for the initial invite by doing that. So it significantly reduces the amount of work the listener service has to do to handle these calls because we don't have to actually handle the entire call. The one weird part about that is that if you get 12345 at like your own IP address, you don't actually know what the original host was. It might be bgn.vc, but also might be a.bgn.vc or webx.com or anything else like that. So we end up rewriting the SIP URI, if it is using SIP, to have the original host. We take the original URI and then URI encode that and make that the local part. So instead of being 12345 at bgn.vc, the data stream that gets actually used is going to be something like 12345%40 bgn.vc at 10.4.4.100, something like that. The listener service, when it receives this invitation, is able to drop the host portion, just extract the local part, and then URI decode it to get the original SIP URI, 12345 at bgn.vc. And then it knows how to redirect. It's able to say that 302 to that URI. So those are the 4 or 5 deep magic implementations that we have. The next part is some other endpoint specific stuff. I think we're doing pretty okay on time, but I just wanted to pause once again and ask if anybody had any questions on what we've covered so far. Excellent. So let's talk about Cisco macros. Macros, the word macro means a lot of things. In this case, it means like JavaScript snippet. And this refers to, you want to have code that runs logic that is provided by the customer, not by Cisco, and you want to run on the Cisco endpoint. Usually you can't run your own code on these things. You just have to call their APIs, which is very limiting. With Cisco, you can actually upload JavaScript to the endpoint. It will run it. And it has access to the API of the endpoint, so you can do stuff like show dialog boxes and join calls and things like that. It runs in this very weird runtime called duct tape, and it has usually very limited CPU and memory. And it talks to XAPI, which is Cisco's endpoint API, over a local WebSocket, optionally configurable to maybe use HTTP, or no, optionally use like a terminal mode. It's really useful if you want to make UIs. It doesn't really have any additional power compared to a listener service just making API requests. Listener services can call the same APIs, and they can even listen for events over like WebSocket or a feedback URL, which is a webhook. Macros are useful not in that they give you more power, but they give you lower latency and fewer like operational components because you don't have another web server sitting somewhere making requests. Running on the endpoint, and it can respond to a button press locally with no network requests in between, adding latency. So that's really cool. It's also very self-contained. You can just like give this to a person, and they'll be able to use it if they don't already have listener service. So people like that. Listener services would have to deal with like maintaining the webhook URL, for example. And if you drop a connection, like especially over WebSocket, you have to resubscribe to all your events. There's a lot more state there. We've built 2 macros that are part of Relay that you can pick from if you want to use them. And we've also made some additional ones that are just one-offs that aren't part of Relay that people have wanted. Ghost Dance is a passcode checker. It solves the problem where the invitation that you try to dial doesn't have the right passcode. It could be you don't have any passcode, like it's not part of the invitation at all, and there needs to be one, it'll prompt you for it. Or there's a wrong passcode in the invitation, maybe it changed, it'll prompt you for it. It'll also check to make sure that you're not going to get stuck in a moderated meeting that you're not the moderator for, because it's very common, you schedule a meeting, you invite a bunch of participants, some of those participants are endpoints. The invitation with the moderator passcode goes to you, the invitation with the participant passcode goes to everybody else, including room systems. So the calendar for the room resource in Exchange or whatever is not going to have the moderator passcode. If you, the moderator, walk into that room and hit join, and it's a moderated meeting, it's going to get stuck at the please wait for a moderator to start the meeting screen in the IVR, even though you, the human being, are the moderator. And there's nothing you can do about it besides whip out your laptop and join the meeting a second time in WMC or Furious or something in screen share only mode, and then make sure that laptop's battery doesn't die, because then the meeting will end. And it's a huge headache. Mostly customers have been solving this in the past by whitelisting individual IP addresses or subnet ranges of where their endpoints are coming from, like their VCS public IP address. And with BlueJeans, you can make rules that say, if an endpoint joins from this IP range, treat it as a moderator without having to ask for the moderator passcode. So it's like consented escalation of privilege, just so that you can get out of this stuck in the moderator screen problem for enterprises which require that meetings have a moderator passcode and not start without one. With this one, it can just ask you, hey, it looks like you're joining a meeting. That meeting requires a moderator, and the meeting's not already started, and the passcode you provided isn't the moderator passcode. Are you the moderator? Do you know the passcode? Maybe someone told it to you. We're going to give you a dialog box with the opportunity to just type it in right now. That way, we will join with that passcode, which starts the meeting. You don't have to whip out your laptop or your phone and start it from there. So that's really cool. Virgin Moon is the second one. That's for Verizon. That was who requested it. And they wanted to replace the star codes for DTMF for doing things like muting and unmuting your microphone on the server side, changing layouts, recording. They didn't want to have to train people to hit the keypad button and then hit the star button and then hit the one button to change layouts, because that makes no sense. And people won't remember that. It's not discoverable. It's not intuitive. So we added a very simple thing that just shows a button in the meeting, and it allows you to see what the options are for your DTMF menu. You just tap on the thing you want, and it sends the DTMF for you without you having to know what a star code is. The last one was just like a wizard to prompt people. It's a joiner thing. So if you are on the home screen and you want to join a BlueJeans meeting, you can get prompted for the meeting ID and passcode, and it will construct the dial string, as opposed to you having to know how to construct a SIP URI out of a meeting ID and passcode. I think someone wanted that once, and we just kind of gave it to them. These are some pictures of what they look like. So this is you're trying to join a moderated meeting that hasn't started yet, and you don't have the moderator passcode in the invitation. So do you want to type it in yourself here? It'll prompt you kind of as you get into the meeting. Then this is the dialer thing where you can just from the home screen type in the meeting ID and join it without having to do like the call button and then the meeting ID and then @ and then bgn.vc. It's just this. Then the bottom two are the Verizon one, where there's an in-meeting button that gets added to the strip at the bottom of your touch panel screen. That has custom icons, all real cool. And then it shows this menu when you tap on it. These all correspond to different star codes, so you can tap switch layout, server-side muting and camera disabling, chat and recording. There are also different buttons if it detects that you're in a Teams meeting, because Teams has other DTMF codes. And I personally use this every single day, because when I join a stand-up, I like to have the constant presence layout so I can see everyone equally. But the meeting default is active presence, active presence. So it's not my meeting, so I can't change the default one. So I always join the meeting and I hit the BlueJeans button, I hit switch layout, and then I see the constant presence layout. So that's super helpful. We have a couple more things. We've got some installers. This is how you install the listener service. We've got Windows, Linux, and hosted Linux in like Azure and AWS. For Windows, it's both an installer and a configurator all in one, and it uses NSIS. It's a very clunky language. It's terrible, but it does what we want. If there's anything complicated we can't do, which basically is anything more complicated than an if statement, honestly, then it runs Java from a temp directory in the background and then uses standard output to deal with that. Linux is a lot more powerful. The installer is separate. It's just RPM or dpackage. We publish debs and RPMs. And then we have a text mode wizard, which is technically just the listener service running a different mode. It uses the internal library. That's how you configure it for auth and things like that. The last one is if you're running on hosted Linux with images from AWS and Azure, we've got pre-built images to use with those. Ben added some build steps to generate these images, and it allows you to not have to install JRE and allows you to not have to SSH into the machine just to access the config. It's a web-based config that he added to that. The last cool thing here is that nobody knows what their EWS URL is. It confuses people to no end. So we implemented Microsoft's Auto-Discover protocol, which is a way of hunting through DNS and HTTP requests to try to guess the EWS URL. Well, first you guess the Auto-Discover URL, and that's the SOAP server that you talk to get the EWS URL. And there are a bunch of fallbacks and things that they specify. So we implemented that. It works really well. It helps people not get confused about how to set that up. Admin UI is our front end for administrators, and this is just a really simple single page app in JavaScript. It's what you use to provision stuff. We've got some libraries like Lodash and Backbone, all these other things, and we build it using Erdnot, which is built by Andrew for all the required JS stuff. And it looks like this. It's just an image. Yeah, here's my enterprise. So we've got an admin page here. It's just meant to be pretty simple and understandable and clean. And the other thing we serve on the web is API docs. And docs are auto-generated on build based on the code of our project. So it looks at the Java classes and methods, any comments we have on those methods for the parameters and everything. And it's always regenerated for every single build. So it will get deployed at the same time that changes to the API take place. So it's never out of date. You never have to remember to go change anything. There's no additional developer steps. You can embellish it, but it's going to be there even if you don't do anything extra. And if it sounds a lot like Swagger, I looked at Swagger and thought it was not customizable enough. So I built my own tool called Harbor, because that's where the docs live. It's got try it now forms, so you can not only look at the docs for requests, but also run it live in your browser with previews of what the request and response look like. And that looks like this. This is another image. And we've got a bunch of recipes for here's how you do all these different things, like figure out my list of endpoints or join a meeting. And we've got all the different data types for our data models or entities. And there's all the different methods that we have grouped into families. So that's how we tell people how to use the Relay API. We've got an Android app. This is not for admins, this is for end users. This shows scheduled meetings. It allows you to do stuff like control an endpoint, joining, hanging up, muting, unmuting, recording. It has some intelligent recording moderator prompts. It lets you run whatever code you want, which is cool, but it is more work to set up operationally than a native touchscreen that you already have for your Cisco endpoint or whatever. So people this was a stopgap before we had DeepMagic, and people don't really use this too much anymore. It's definitely a lot less popular than DeepMagic because DeepMagic is so integrated with the native UI of the endpoint. People like that. Don't have to worry about someone stole the charger off the Android tablet. So people don't really use it a whole lot, but it was very cool. It is very cool, and it was very fun to write. It looks like this. We've got just a list of meetings, and you can tap on them. And Alexander said, can we make a calendar API for this, or a calendar function for this relay thing? I said yes, and he bought all these Android tablets for us. So these are a bunch of Nexus 7s that we unpacked and were able to get working with ICE. This is the boardroom with an old UI of that, including when we used to have QR codes in here, which is fun. But that's ICE. Got a couple more things. This is mostly just cool stuff that we have architecturally. We've got code sharing. So we share code between a couple different projects internally and externally. Storm client is kind of like the docs. We auto-generate a Java REST client for the API in Storm. This means we don't have to write a server-side method in Storm and then turn around and write a client for that method in all of our different clients or forget to update them. It's just generated automatically. You just use them. Same benefits, same reason to do it, uses the same build system with Harbor. Catalyst Common is code sharing between our different libraries. So if you need to add a class like a data entity to Storm and then have it be used by the listener service once it gets deserialized over JSON, or maybe also to ICE, same API, you just have that all in one library and then share that library between all the different consumers. So you don't have to like update it in two places. If you add it to the server and the client, it's great. We're trying to get a lot of the good parts of SOAP without the bad parts. So we're also trying to use JSON, not XML. So we tried to strike a good balance there of being helpful without overbearing. There's also cross-project sharing. Helios has sharing for two different things. One is how to write a good Java app server. We've extracted a lot of the stuff that was kind of more boilerplate, like the common between Storm and the Storm's counterpart in the Rooms land, which is called Polaris. There's also common business logic, not just how to write a Java app server. So a lot of SIEM requests, things like that. How do you talk to different SIEM services, prime time? That's all in Helios. We can both use it. We've got some cool testing stuff we do. Like many projects, we have a bunch of unit tests. They run on when the module's built. We also have layer tests that test broader things and integrations. We've got a pretty cool way of doing in-memory API tests. So you don't have to do a separate package. You don't have to run a separate server. You don't have to have any separate dependencies like a database or a message queue or even be connected to the internet. You don't have to worry about, am I going to be able to prevent requests from going out to like the real Mixpanel server? No, you can mock all that out. You can have all sorts of different fixtures that you want. So you can have fake data coming in from like, GET requests that would normally go to a database. Those are all mocked out. It runs Jetty in the same process as the unit test, basically, in-memory Jetty. And it's able to, that means that the unit test can reach into the Jetty service and white box it with mocking things to establish boundaries. That was extremely difficult to get working, but it's really cool that we have it. It's really good for validating things that aren't suited to unit tests, such as serialization, which is, did you set up your entire REST stack correctly? Authorization, did you set up your entire authorization stack correctly? Those aren't units, they're much bigger than units. They can be broken along at many different constituent units. So being able to test all of those gives you confidence that you wouldn't get from, well, I have 4 units and I have 4 unit tests and they all pass. So there are probably no problems once we like combine these together and compose them. This allows us to do everything at that level. We've also got UI tests. We use Casper and Roboelectric for web and Android respectively. We've also gotten the Jersey way of mocking out HTTP requests is terrible and inflexible. It's just so bad. We wrote our own. We're able to mock out HTTP requests and validate them. It turns out builder patterns are great for expressiveness when you're using the API. They're hard to write and they're really hard to test. So we had to put a lot of effort into that. And then for SOAP, it's just a thicket of nonsense. So we're able to mock out our SOAP requests that would go to a Cisco endpoint and have those be verified that we're doing the right thing there. This is all separate from what QA does. This is just developer stuff. QA has a gigantic amount of other tests, not even just manual stuff, but automated tests. James has been adding a ton of Android automation recently for UIs. So these two things add to each other. This is not all we have. We have this custom way of, if you want to do some cool stuff with an endpoint, but really doesn't support the endpoint that you want to use, or you want to do something that isn't even an endpoint, or you want to do something where you want a listener service to treat you like an endpoint, but you don't want to have to imitate a Cisco API. We've made this protocol that we just invented called Mesh, and it allows us to have basically a stub implementation of what a Cisco endpoint would be, or any other kind of endpoint. So if you want, you can make a web server, you can implement the methods that are defined in the Mesh protocol, And then you can tell Relay that you have an endpoint with the IP address of your web server, tell it to use the Relay Mesh control protocol, and then listener service will start calling your custom web server, telling it to join meetings and things like that. So you can use this for adding support for unsupported endpoints. We did this for an example for the Tamberg 1000 Classic. One of the older endpoints we have access to. It's terrible, but you can actually use it with some web scraping and some telnet. And the example project that we put on GitHub is how to use Mesh to add support for an unsupported endpoint in Relay. The example is the Tamberg 1000 Classic. It's a fully featured example. There are also a bunch of skeleton projects that aren't about Tamberg 1000 Classics, but they're just about how to handle requests in a couple different languages, like Python and JS and PHP and stuff like that. And the last thing, we have -6 minutes left, is some cool integrations that have been built upon this platform that is Relay. Luke's big code contribution, besides being a tireless supporter of us, was the phone app, a fork of Acid that had a QR reader, which got us a patent, and the Bluetooth Low Energy client, which was able to transfer calls from the phone that you're currently already in or from a meeting that's on your meeting list from the phone onto a nearby third-party room system, which you might recognize as Zero Touch. Yes, Luke did that 9 years ago. So that was one of the first things that we demoed Relay with. The gesture recognizer that Luke added was it can detect when you want to do that whole Zero Touch thing by slapping your phone on your ass. It was a hit in demos. There was a hackathon project that I participated in with that photo. That was you scan your employee badge, which is an RFID badge, onto this reader, and it knows how to join your personal meeting onto some endpoint with Relay. It also knows what color to light the room with, your favorite mood lighting, and it knows what flavor of aromatherapy you want to smell during that meeting with this tower of stuff that we hooked up. So that was a blast with Vanessa, Charlie, and Nick, and it showed what an incredibly powerful platform Relay is if you care about aromatherapy and mood lighting. We had this pulse dialer thing that I set up. This is a rotary phone that I've had for forever, and it's not tone-based, it's pulse-based, so it's super old, and I was able to write a Raspberry Pi program that interprets the pulses this thing emits for the different numbers that you dial, converts that into a meeting ID for BlueJeans, and then uses the Relay API to cause an endpoint to join that meeting. So my personal meeting, 10990, I can dial 10990 with all of the Spring-based send back that is involved here. And then you're in my personal meeting on a real endpoint, which is really, really awesome. There was also an engineering hackathon where I made a Moto 360 smartwatch dial into BlueJeans meetings with Relay. So the idea is that you can build upon this thing. It's not a self-contained product that no one else can use, or that they can only use it as a consumer or like an end user. They can use it as a real platform to build other things on top of it with this functionality we've provided for unifying these different endpoint APIs. I think that's the value of Relay. That's it. That's the whole presentation. We've got -9 minutes left. So thank you so much for watching, and I would like to answer any questions or comments you have at the end of our podcast. Any callers? I really didn't think we would get through that in an hour and a half.
I don't have any questions, Ben, but great presentation. Thanks for going through the whole history of Relay and how everything works. That was very educational.
Yeah, thank you. I'm glad that you liked it. And also thank you so much for being a part of this journey and for all the hard work you've put into it.
Cool. Cheers, Ben.
Cool. Well, we can take any other questions, or if there aren't any, give you your respective, we get back to your respective holidays or evenings or mornings, depending on where you are. I
Cool.
know
Cheers,
there's
Ben.
a public holiday in New Zealand today, so
Yeah,
let me get back
Matariki.
to enjoying that. Also in Canada,
Cheers.
I learned there's also a different non-Maori based holiday in Canada occurring today.
Yeah.
I don't know if anyone here is Canadian, but if you are, happy Saint Jean Baptiste Day.
Cool. Cheers, Ben.
Cool. Thank you so much, everybody. I hope you have a great rest of your day. And thank you for joining and listening to my podcast /bootcamp.
Thank you.
Thanks.
Thank you, Ben. Much appreciated.
No problem.
Thank you.
All right, take it easy, everybody.
See ya.
Bye.
See you.